Hello and welcome to the first worksheet for connected particles and pulleys. This is a topic from the M1 syllabus. So if you are doing your A-level math and you are attempting the M1 component this year, this video is for you. There are about 10 questions that I will be solving for you. Let's start with the first one. Question number one says particles A and B of masses zero point 0.2 and 0.45 kgs respectively are connected by a light inextensible string of 2.8 meters. Okay, so there's 0.8 meters, 0.7 meters here. The string passes over a smooth fixed pulley at the edge of a rough horizontal table, which is 2 meters above the floor. Okay. Particle A is held in contact with the surface at a distance of 2.1 meters from the pulley, and particle B hangs freely in the diagram. The coefficient of friction between A and the surface is zero point 0.3, so mu equals to zero point 0.3. Particle A is released and the system begins to move. Find the acceleration of the particles and show that the speed of B immediately before it hits the floor is 3.95, correct to three significant figures. And it's 7 mark question. So let's start drawing up our equations. At B, it's simple. This is 4.5. There's an upward force of T. So at B, it's relatively simple. The particle is going to move down. I'm going to say that 4.5 minus T equals to 0.45 A. At A, it's a little different. Okay, at A, it's a little different. Let's draw the forces. There is a mass of 2, a tension of T, zero point 0.3 into 2. Why 2? Because R is going to be 2. Okay, so R is 2. The frictional force equals to zero point 0.3 into 2. So I'm going to say that T is going to drive the particle. There is zero point 0.3 into 2 resisting the motion. Okay. Is there any other force resisting the motion? No, there's no other force resisting the motion. So I'm going to say that this becomes 0.2a. So I have two equations that I want to solve simultaneously. 4.5 minus t equals to 0.45a. I will first solve for the system, then I'm going to use um, constant acceleration formulae v equals to u plus at and so on to solve for um, the velocity that I have to prove to you. So t minus zero point 0.6 equals to 0.2. Okay, so acceleration is 6. Then the starting speed is 0, acceleration is 6. How much does the particle have to move? The particle is at 2, the leftover part of the string was 0.7, so it has to move a distance of 1.3. So I'm going to say that it has to travel 1.3 meters. So v square equals to u square plus 2as. Let's see if that gives us the correct answer. 0 square plus 2 times 1.3 times 6. 2 into 1.3 times 6. 15.6. And the root of 15.6 is 3.949, which gives me 3.95 approximately. So relatively small 7 mark question because there were lots parts involved. Making sure that the diagram is correct is marks as well. So make sure that you do that correctly. Given that B remains on the floor, find the speed with which A reaches the pulley. Okay, so A is right now, its wave was 2.1 meters away. Now, how far is it from the pulley? I'm going to say that this is 2.1 minus 1.3. Okay, that's how far away from the pulley it is. So it has to travel a distance of 0 0.8. A has to further travel a distance. Now, what are the forces driving A? There is a tension that's equals to 0 now. Remember that when one particle touches the ground, the system sort of breaks. System breaking does not mean that the string is broken, but the string has become slack. When it becomes slack, its tension becomes equals to zero. Okay, so when the tension is zero, there is no driving force involved right now. There is a friction force of zero point 0.6, which is resisting the motion. So let's solve for particle A. At A, what is happening? There is zero driving force. There is a zero point 0.6 resisting force, and the particle is still moving, which means that it must be decelerating with the speed of with an acceleration of -3. So S is zero point 0.8, acceleration is -3. Now, the ending speed of the last part of the motion is the beginning speed of this part of the motion. So it's starting off with a speed of 3.95. I am asking you, find the speed at which A reaches the pulley. So it's going to reach the pulley, and I'm asking you for the final speed. So again, V square equals to U square plus 2AS. Okay, so let's try finding that. 3.95 squared plus 2 times zero point 0.8 times minus 3. 10.8. Okay, root of 10.8. 3.29. Is that the correct answer? Yes, that is the correct answer, meter per second. Okay, that's the first question on connected particles and pulleys. Let's look at question number 2. It says particle A of mass 0.26 kgs and particle B of mass 0.52 kgs are attached to the ends of a light inextensible string. The string passes over a smooth fixed pulley P, which is fixed at the top of a smooth plane. The plane is inclined at an angle of theta to the horizontal, where sine theta equals to 16 over 65. Okay, sine alpha. I will also need cos alpha, so let's just quickly put that down. How do I do that on my calculator? I'm going to show you my calculator quickly and show you how I can get. Okay, I'm going to say sine inverse of 16 divided by 65 cos of answer. Okay, why is this not coming up? I think my calculator is set to a different mode, so 63 over 65. Okay, so that is cos alpha for me. It says A is oh, okay, that was given for me. I shouldn't have calculated that. Okay, A is held at rest at a point 2.5 meters from P with the part AP of the string parallel to a line of greatest slope of the plane. B hangs freely below P at a point zero point 0.6 meters above the floor. A is released and the particles start to move. Find the magnitude of the acceleration of the particles and the tension in the string. Okay, so I will have to work on my diagram. So at B, what's happening is this is 5.2. It's being pulled up by T. So 5.2 minus T equals to 0.52 A. That's happening at B. What's happening at A? I will have to resolve the forces here first because there's some resistance to the motion as well. um, Smooth plane, so no friction involved. This is 2.6 sine alpha. Okay, there is an R involved here, but there is no need for R right now because I don't have friction. I don't need to worry about that. So at T, what is happening is 2.6 sine alpha. So sine alpha was 16 over 65. Let's write that, and 0.26a. Okay, the speed of the magnitude of the acceleration and the tension. So T cancels out. What does that give me? It gives me 5.2 minus 2.6 into 16 over 65 equals to 0.78a. So acceleration is 5.846 which rounds off to 5.85. Okay, and 76 over 13 if I'm taking an exact number. I'm going to take the exact number for calculating tension so that I don't have a lapse there. 76 over 13. Okay, so 0.52 into 76 divided by 13, 5.2 minus answer. That gives me 2.16 newtons. That's part one. Let's look at part two. It says the speed with which B reaches the floor and the distance from A from P when A comes to instantaneous rest. Okay, so again, let's start off with our calculations. Okay, the speed with which B reaches the floor. So B has to travel a distance of 0.6. It's traveling with an acceleration of 5.846. It has a starting velocity of 0. I'm trying to find V. So V square equals to U square plus 2AS. V square 0 square 2 times 0.6, 2 times 76 over 13 into zero point 0.6. Okay, I'm taking 76 over 13 as the acceleration just to get a more precise answer. It's not necessary though, and you can choose your own answer. It gives me 2.649, which is equals to 2.65. So with the speed with which B reaches the floor is 2.65. Now remember that when B reaches the floor, A has also moved a distance forward. Okay, how much has A moved forward? It has moved forward a distance of zero point 0.6. How far is it away from the pulley? And the distance of A from P when A comes to instantaneous rest. It's already moved zero point 0.6. I want to find out how much further A will move forward. How much further A will move forward when it comes to instantaneous rest. So once the system breaks, okay, what happens when the system breaks? A is on an inclined plane, so its driving force suddenly becomes zero. It's still being resisted by the gravity that's there. So 2.6 times 16 over 65, 2.6 sine alpha. So I'm going to find the new acceleration. I'm going to say that the particle will now start decelerating and it's going to move with the speed of with an acceleration of, let's first find the acceleration. So acceleration is minus 32 over 13. So now its starting speed is going to be 2.649, which is 2.65. I think that's a reasonable rounding off. It's accelerating or decelerating with minus 2 over 13. How much distance will it move forward? When it comes to instantaneous rest, which means that the velocity must equal 0. So again, v square equals to u square plus 2as. 0 square 2.65 squared 2 times minus 32 over 13 and s. So s comes out as 1.426. S is equals to 1.43. It says what is the distance from A to P. So I'm going to say that the original distance was 2.5. First, it traveled the zero point 0.6 with the system when B was hitting the floor. A was also moving forwards, zero point 0.6 there, and then 1.426 here. Okay, let's see if we get the correct answer. I have a feeling there is some. I am getting 0.474. It says 0.475. Maybe there's a rounding off. issue. I think that is not something that we should be focused on right now. And I think this is a reasonably fine answer. Okay, so 4.74 meters. That was this question, a long question for 11 marks. Okay, moving on to question number 3. It says two particles P and Q have masses m kgs and 1 minus m kgs. Respectively, the particles are attached to the ends of a light inextensible string which passes over a smooth fixed pulley. P is held at rest with the string taut and both parts vertical. P and Q are such at a height of h meters above the ground. P is released from Q, and Q moves downwards. Subsequently, Q hits the ground and comes to rest. So we know that Q, it has to be heavier because it's moving down. Q hits the ground and comes to rest. Figure 2 shows the velocity time graph for P while Q is moving downwards or is at rest on the ground. Okay. Find the value of H. Okay. So these two graphs are related to each other. There are two things about this graph. Uh, One is that whatever acceleration I get from here is the acceleration of this system. Okay, so what is the acceleration I'm going to get from here? This point is 0.5 comma 2. So I'm going to say 2 minus 0 or 0.5 minus 0. That gives me 4. So it's accelerating at 4. What are the forces involved? There's 10m and 10 into 1 minus m. Okay, there is a t and there is a t as well. Okay. Now the first question that I'm asking you for 2 marks is just to find the value of h. Okay. So what distance is p moving with this first acceleration? It's this distance. I'm going to say that the area under the graph is going to represent the distance. So half into 2 into 0.5. So that's 0.5 meters. Okay. So that was simple. I don't need to go into tensions and accelerations and so on. I found the acceleration though, which is going to be used in the second part. So find the value of m and also hence find the tension in the string while q is moving. So in this case, p is moving up. So at p, what is happening is t minus 10m equals to ma. And a is how much? Is 4. That's what I calculated. At q, I have 10 into 1 minus m minus t equals to 4 into 1 minus m, ma. The mass is 1 minus m, 1 minus m kgs. Okay, so I have m as the unknown, t is cancelling out, so I have minus 10m plus 10 into 1 minus m equals to 4m plus 4 minus 4m. Okay, I've added these two and I've added these two. So minus 10m plus 10 minus 10m equals to 4. 10 minus 4 equals to 20m. 6 divided by 20. But 6 divided by 20, yes, it is zero point 0.3. Okay, so I know that the mass is now 0 point 0.3. What is the tension in the string? T minus 10 times 0 point 0.3 equals to 4 into 0 point 0.3. T minus 3 equals to 1.2. 4.2. Okay, then the third part says the string is slack while Q is at rest on the ground. Find the total time from the instant that P is released until the string becomes taut again. So after this system sort of breaks, when Q hits the ground, P is going to move freely under gravity. Okay, P is going to move freely under gravity. It's going to go up and then it's going to come down. Uh, and when it's doing that, it says find the total time from the instant that P is released. So how much time has it spent right now? It spent point five seconds while the system was active. So the acceleration was 4, Q was going down, P was going up. and I had an acceleration of 4. Once that system breaks, the acceleration will automatically be minus 10. It's going to move freely under gravity, so that's what is going to happen here. So this gradient is also minus 10. Let's see if we have to use the graph, or we can do it otherwise as well. So what is happening after the system breaks on parts 3 is that the acceleration is minus 10. Okay. P should have a starting speed. P had a starting speed of 2. That's what I can say in this part of the motion, that when that system has changed, the acceleration has changed, has a starting speed of 2. Okay. And it's going to reach a maximum point. Okay. It's going to reach a maximum point where it reaches a velocity of 0. I want to find out how much time has passed, so I'm going to find out the time. Okay. So my V equals to U plus 80, 0 to minus 10t. T equals to zero point 0.2. Okay, T equals to zero point 0.2, and for going up, T equals to zero point 0.2 for going down. Okay, T equals to zero point 0.2 for going up and T equals to zero point 0.2 for going down. That's what we've decided. So this would be 0.7 and 0.9. How much time has it spent before? It's 0.5 seconds that it spent before. So total time is 0.9 seconds. 0.4 plus 0.2 plus zero point 0.2. Okay, so I found all of these points. I could have just used the graph actually. I could have used the gradient formula and found these points. Uh, but it's your call if you want to use the diagram or use constant acceleration formula. Okay. Let's move on to the next question. It says a smooth inclined plane of length 2.5 meters is fixed with one end on the horizontal floor and the other end at the height of zero point 0.7 meters above the floor. Point P of mass is 0.5 kgs and zero point 0.1 kgs respectively are attached to the ends of a light inextensible string which passes over a smooth fixed pulley fixed at the top of the plane. Particle P is Particle Q is held at rest on the floor vertically below the pulley. The string is taut and the P is at rest on the plane. Q is released and starts to move vertically up towards the pulley, and P moves down the plane. So P is moving down and Q is moving up. Okay, that's sort of the reverse of what was happening. It's because of the weights. Okay, the weights are in such a way that P has to move up. Okay, so this is 0.5, so 5. So that's 5 sine theta. Okay. Can I find out theta first? Theta is basically, I see this right triangle in front of me, so I can say that theta is sine inverse of 0.7 over 25. So sine inverse sine theta is zero point 0.7 over 25, 2.5, sorry. That gives me 7 over 25. Okay. So I have that. Um, Otherwise, it's a smooth table as well, does it say? Smooth inclined plane. So I don't have to worry about friction right now. Okay. Find the tension in the string and the magnitude of the acceleration. So it's a simple question. So this is T. This is also T. This has a downward force of 1.1 is the weight. So 1 downwards. So at Q, what is happening? It's moving up. T minus 1 equals to 0.1 A. At P, what is happening? The particle is moving downwards. So 5 sine theta. What is sine theta? It's 7 over 25 minus t equals to 0.5a. Okay, minus 1 plus 35 over 25 equals to 0.6a. So acceleration is equals to 2 over 3. Okay. Tension is simple then. T minus 1 equals to zero point 0.1 into 2 over 3. T equals to 16 over 15. At the instant just before Q reaches the pulley, the string breaks. So it hasn't reached the pulley. Just before Q reaches the pulley, the string breaks. P continues to move down the plane and reaches the floor with a speed of 2. Find the length of the string. Okay, so just before Q reaches the pulley, the particles should have traveled a distance of zero point 0.7 with an acceleration from the previous part. They started off with 0. So I will need to know what speed was there at the end so that I can decide about A's journey from there on. Okay, so V square equals to U square plus 2AS. V square equals to 0 square plus 2 times 2 over 3 times zero point 0.7. V square equals to 14 over 15. V equals to 0.966. That is the speed. Then it's saying that once this string breaks, what you need to again understand is that once the string breaks, Q A is right now then moving just with its downward force, which was 5 into sine of theta, which was 35 over 25 basically. There's no tension resisting it anymore. Okay, and I think it should be accelerating rather than decelerating. Okay, so let's see what is happening. There's no tension resisting it, so 5 times 7 over 25 minus 0 equals to 0.5a. Okay, so let's see. So acceleration is 2.8. It started off with a velocity of 0.966. It's accelerating at 2.8. I want to find the length of the string, so I'm going to say that I want to find out S. I'm talking about distances right now. So I'm going to find out S. It has an ending speed of 2. So V square equals to U square plus 2AS. 2 square, 0.966 squared, which is 14 over 15. Okay, 2 times 2.8 times S. So 2 square minus 14 over 15 divided by 2 divided by 2.8. 0.548. Okay, so what should be the length of the string? P has, okay, now this is a little complicated because I'll have to do this on the diagram. So P has total traveled a total distance of how much? It has traveled a total distance of 0 0.7 first and then 0.548. Okay, 0 0.7 and 0.548. Okay, that is the distance that it's going to travel before it hits the ground. Okay, so how much is then left over in this part? I'm going to say that this part has to be 2.5 minus 0.7 minus 0.548. So that is the string on this part. What is the total length of the string? So I'll have to add another 0.7 here as well. So it's just 2.5 minus 0.548. That gives me what? That gives me 1.95 meters. Okay, that's question number 4. Let's do question number 5. It says a particle A of mass 1.6 kgs rests on a horizontal table and is attached to one end of a light inextensible string. The string passes over a smooth fixed pulley P. fixed at the edge of the table. The other end of the string is attached to a particle B of mass 2.4 kgs, which hangs freely below the pulley. Okay, the system is released from rest with the string taut and with B at a height of 0.5 meters above the ground, as shown in the diagram. In the subsequent motion, A does not reach B before B reaches the ground. Given that the table is smooth, okay, so let's first find the time taken for B to reach the ground. So B has to travel a distance of 0.5. I want to find the time. I know that its starting velocity is 0. I will have to draw up the system if I want to find out the acceleration. Okay, B is of mass 2.4, so 24 t 1.6 t. Since there's no resistance to the motion at a simple thing is happening. It's t minus 0 equals to 1.6 a, and then 24 minus t equals to 0.24 a. Oh, sorry, 2.4 a. Okay, so 24 equals to 4a equals to 6. The acceleration is 6, t0, s 0.5, and I want to find, sorry, t is what I want to find. U is 0. Okay, so s equals to ut plus half at squared. Okay, so 0.5 divided by 3, and the root of the answer gives me t equals to root 6 over 6 seconds. Okay, given instead that the table is rough and the coefficient of friction between A and the table is 3 over 8. Okay, so R 3 over 8 times R, which is 16. R has to be 16 because there are no other upward forces involved. Find, and the table is 3 over 8. Find the total distance traveled by A. So with the system, A is going to travel a distance of 0.5. The time that it's going to spend is root 6 over 6. Okay, you may assume that A does not reach the pulley. So it's going to have a starting speed. The ending speed at this would be, I will have to find it out here. I'm going to say that V equals to U plus AT. So 0 plus 6 times root 6 over 6. So that gives me, I think, root 6. Okay, so ending speed was root 6 after the system, which means that A has reached the ground and there is no tension anymore. So I'm going to say that at A, what is happening? There is nothing pulling the. Oh, I think, no. What you'll have to do is you'll have to rework with the system as well, because it's a 7-mark question. Let's start off with the system. At A, what is now happening is T minus 3 over 8 times 16. I think this was irrelevant here. Equals to 1.6 a. So at B, what is happening is the same thing because there are no forces that are changed there. 0.4 a. So So 18 equals to 4a, 4.5a. 4.5 equals to a. So a equals to 4.5. U is 0. I want to find out v specifically. And I know that with the system, I'm going to travel a distance of 0.5. So v square equals to u square plus 2as. V square u square 2 times 4 point times time times 0.5. So I'm getting v equals to 4.5. V square equals to 4.5 and v equals to 3 root 2 over 2. So that was with the system. Now after the system, the tension is going to go down to 0. So I'm going to say that 0 minus 3 over 8 times 16 equals to 1.6a and t minus 24, sorry, 24 minus t. In fact, I don't need b right now because the system is broken, right? So at a, that's what's happening. So I'm getting minus 3.75. So now the particle is decelerating. It started off with the speed of 3 root 2 over 2. Its acceleration is minus 3.75. I want to find out how much distance it has traveled. So I'm going to say that S is what I want to find out. I know that the particle stops before it reaches the pulley. So V equals to 0. So V square equals to U square plus 2as. 0 square 3 root 2 over 2 squared plus 2 times minus 3.75 times S. S equals to 0.6. Okay, so total distance traveled 0.6 plus 0.5, which is 1.1 meters. Okay, so that is where we'll stop this video. I'll be back with more questions in the next video. Thank you for watching and please make sure to like and subscribe. Thank you.